I'd like next to introduce Nick Feamster. Nick's from Georgia Tech. And Nick is going to talk about his uCaps project, which is an OpenFlow-based app which leverages an existing campus deployment that he has at Georgia Tech to provide usage cap management at a home user level. So, thanks.
Thanks, Mark. So I'm going to talk about work that we've been doing with Russ Clark, who's here in the OIT department at Georgia Tech, as well as several PhD students and postdocs. This is primarily the work of PhD student Jun Kim, who couldn't be here today because he's presenting at IMC in Germany. So basically what we're looking at is how software-defined networking and GENI can make network management easier. So we've heard about software-defined networking, but we haven't heard much about software-defined network management. So that is basically what this talk is about. As we know, network management is very hard. It's manual, error-prone, and complex. Configurations are changing continually due to new users, devices, adjustments to access control, response to various incidents. And a lot of these changes can create errors. Here's one that I pulled off of the Georgia Tech page just a couple days ago, where a configuration error to a router caused some downtime. This is, of course, not specific to our network, happens everywhere. So basically what our research is exploring is how software-defined networking can play a role here. We already know that software-defined networking makes it easier for network operators to evolve certain network capabilities, but how can it also help network operators manage their networks once they're actually deployed? And we're doing this in the context of two different case studies. One is with campus or enterprise networks. I'll talk about that. And the other is in homes, where unfortunately the network operator is you, whether you like it or not. So before I get into our solutions, I'm going to just briefly highlight why we think network management is so difficult today. I think there are kind of four main reasons. One is that configuration is very complex and low level. A campus network can have, of course, more than 1 million lines of configuration, thousands of devices, hundreds of changes every year. Home networks are pretty complex as well. The diagram I've shown on the slide here is someone's home network diagram, which I've pulled off of the ratemynetworkdiagram.com, which is like the hot or not of home networks. This one's pretty hot, of course, but probably very hard to manage. Another thing that makes configuration rather tricky is that state's always changing. Right? In particular, enterprise and campus networks are pretty dynamic, with hosts coming and going all the time, hosts becoming infected, and so on and so forth. The same is true in homes as well. People are introducing new devices all the time. You have guests entering your home network, and so on and so forth. Unfortunately, network configuration today is quite static. It's poorly integrated with these, the notion that things are continually changing. So basically what we're doing is looking at how we can use software-defined networks to actually inherently incorporate some notion of dynamic control into both home and campus networks. The idea is basically that we'll track, we'll use software-defined network controller to track the state of each host on the network, and use that controller to update the forwarding state in switches and routers and so forth for each host as the state of the network changes. And you can imagine many possible states, ranging from the introduction of a new device to a compromise to, for example, as I'll show you, someone exceeding their usage cap in a network. Another problem is too much complexity is exposed. I won't belabor this given the limited time, but of course we've already seen these, these types of, rather daunting network interfaces. And what I'm going to hopefully show you is we've got something that's a little more intuitive. Last thing, of course, is that devices are heterogeneous. There are a lot of things in a campus network, of course, where things are bolted on somewhat after the fact as the need for new functions arise. And the same thing goes for homes as well. As new technologies come, people are continually adding all kinds of Wi-Fi enabled and network enabled devices to their home networks. Unfortunately, a lot of these devices have separate, distinct interfaces, different ways of configuring and managing them, et cetera. There's basically no unified way of doing so. Basically what we're doing is looking at how SDN, in particular OpenFlow, can allow us to solve some of these problems. In particular, let's think about, essentially not necessarily configuring the network and configuring hundreds or perhaps more devices, but rather thinking about it as a program, right? So let's program the network. Instead of configuring networks with low-level distributed vendor-specific configuration, let's write network policies and protocols as programs, recognizing that our network configuration is nothing more than basically a program that's that should be processing events, right? Things are always happening, as I mentioned. And what that program or configuration allow the operator to do, or the user, is basically say what happens, or what should happen when a particular event occurs. If we can do that, hopefully we can get rid of a lot of those changes that both home users and operators need to make. So that's the idea behind Resonance. I don't have time to go into all the different ways we sort of approach the 4 problems that I listed, but I will talk a little bit about how we handle dynamic state, because that's what I'll show you with the demo. Basically what we do there is we at the controller, we incorporate a notion of a state machine. So every host on the network has a state, and the controller is basically keeping track of the state which that device is in, and based on the state that it thinks the device is in, it's telling the network switches to do things, to forward traffic in a certain way or not. So you can imagine when a host arrives, it's in some kind of registration state where it can't do much except perhaps go to the authentication portal. If that device successfully authenticates, then perhaps that authentication portal will tell the controller, oh, we've got a successful authentication. That's an event. That should cause a state change at my network controller, and correspondingly, the next thing should happen, right? If, on the other hand, authentication should fail, then of course we don't want that device to be able to send traffic. Maybe we want to quarantine or garden wall it in a different way, and our controller can update the forwarding table entries of switches correspondingly. So we've got a state machine to kind of encode the configuration of Georgia Tech's campus authentication framework, and we've got that deployed across 3 buildings, 5 OpenFlow switches, and a software-defined network that's running Knox, FlowVisor, and this Resonance programming environment, which I've briefly described to you. In the future, we're going to basically also put this in the Georgia Tech Aware Home deployment, which, if you don't know, is basically a real network home that's sitting right off the campus. Why are we doing that? Well, turns out network management is hard, but home network management is even harder for all the reasons I mentioned, but also because we have unskilled network operators, i.e., or unskilled or perhaps uninterested, right? People who don't care to spend their entire spare time managing their home networks. So what are we doing about that? Well, we have this project. It's called Bismarck, and essentially what it is software-defined home network management. So the idea is we have a router, much like the one I've shown here with the webcam. I'm going to basically show a live demo with that. It's a Netgear Wonder 3700. It's running OpenWRT, an OpenFlow module that we've installed on it, as well as a bunch of custom measurement framework that we've built. Currently, it's running active and passive performance measurement and monitoring, as well as some capabilities for home network management, which I'll show you in the demo. Planned, however, basically what we envision is that the applications that I'm going to show you are just one example of the types of things that we can run on these routers. So what we envision is basically this will be the software-defined network platform for the home network, right? So this is GENI at home. We've currently got 42 nodes deployed across 26 locations in 6 different countries. I've shown you a map here. And we're working with some of the Ignite partners as well to sort of build out our deployments in those areas. So if you have applications that you're thinking about for Ignite, we'd love to partner with you or talk about partnering with you, because this should hopefully lower your barrier to entry into actual home networks in those regions. Okay, so this basically summarizes what I've already said, so I'll skip through that. And basically what I want to do now is show you essentially one example application, which is usage control in a home network. I showed you that very ugly interface, right? And you could imagine that doing certain things with that, very primitive things. But what if I want to do more complicated things? Like, so for example, parental controls or management of how the bandwidth is used. Well, this is a very real problem, right? As we know, Comcast, AT&T, Rogers, many other ISPs have put in usage caps, ranging anywhere from tens of megabytes to 250 tens of gigabytes to 250 gigabytes. In some of the developing countries we've looked at, the caps are even lower, like 3 or 4 gigabytes a month. So you can imagine in a case where the caps are very, very tight, or perhaps in cases where they're not, but you're doing a lot of things like streaming, you might want to control what kind of, what devices and what users inside a home can use those devices. And, with the interface I showed you before, that's actually very difficult, right? And in fact, not possible, because those types of knobs are not shown. what I'm going to show you here, and basically what's shown on the other screen, is exactly this demo. Essentially what we have is there's a Bismarck router sitting right here, running OpenFlow. It's being controlled from a Resonance controller that's sitting at Georgia Tech. And essentially what we can see here, let me just grab this, I'll sit over here. What we can see here is essentially a breakdown of usage by different devices in this home. This happens to be the GEC 12 household with sort of a breakdown of different devices we have associated to it. So we've got Russ Clark's laptop and iPhone here. We've got my laptop and my iPhone. We've got some other unknown device. So here's another advantage too. You can see, who the heck is that, right? We don't know who that is. So actually what I'm going to do is cut them off. So what we can do is actually put a cap for each one of these uses. Sorry, whoever you are, I'll turn this back on after the demo. So I've cut that person off. The other thing we can do is sort of look at the usage of individual devices. So I could say, I don't like the way that my devices are using the usage cap. It looks like, well, let's just say that, I think that purple sliver is just too much for me, right? Well, I could see, okay, well, this device has used, 23 megs of whatever I've got so far. Let's say that I want to sort of limit that more. Well, what I could do is basically go down here, and I can say, well, let's just make sure that I can't use more than 25 megs. And then what we can do is go back here, and I'll essentially show you. Okay, so now we've got 25 megs. Now this phone, which I'm about to show you, is associated to this access point right here. And what I'm going to do is start streaming a YouTube video. We are loading. So what we should see eventually is that cap start to go up. Oh, hi, Mark. You're reflected in the thing. Oh, let me just hit play here. Play. Yeah, there we go. Okay, so we should, oops. Play. Yeah, now it's playing. Should get a video up. Now you can see that counter go up. Now we're at 24 megs, right? And pretty soon here we're going to see this device get cut off. Hopefully. Well, it will happen eventually. I'll just finish the presentation. Okay, so in conclusion, oh, there we go. I am capped. I have now cut my iPhone off the network. I'm stuck back on the hotel network. So you can see basically this is something that would have been very tough for me to do given existing type of management framework. But as I've mentioned, we believe many of the problems with management of both enterprise and campus, enterprise campus and home networks result from the fact that configuration is too low level, it's too distributed. If we can view instead the network configuration as a distributed program and sort of program it from a logically centralized controller, we can do things like Resonant, that state-based kind of configuration that allows for much more sort of high-level configuration of the network, handling of dynamic events, for example, the exhaustion of a usage cap, and also provide us interfaces that are much more intuitive, like this one that I've shown you, that we just don't have before. So just to conclude, I've shown you these, I've described these two case studies. If you'd like to learn more, you can go to projectbismarck.net to learn more. As I mentioned, this is one example application, but as we're deploying these nodes both around the world and in Ignite cities, we view this as an SDN app platform that hopefully others will use as well as part of their GENI and Ignite experiments. Thank you.